And 1 2 test test. Hello, hello. Perfect. Welcome back to another late night calculus stream. Today we're gonna be not introducing anything new. We're gonna be doing some mixed reviews. That's right. When you go on Steam and you see a game has mixed reviews, it's because all the reviewers are actually doing calculus. So, anyways, let's get started. First off, we have, why is this not working? A little problem. Actually, not little at all. Something's wrong. Let me try doing this. Okay, now it's a little better. Wait. No, that... What is wrong with this? Oh my god. Why is this breaking? Okay. This is a little better. We're gonna start off with volumes by revolving around a given axis. So I think this is volume with cross sections. Let's call it volume. Let's just call it volume. All right. One has how many parts? There's at least 4 parts. 4 questions for number 1. A wants to know the volume of the region by rotating the area bound by x equals 0, y equals 3, y equals square root of 3x about the y-axis. So let's sketch a graph real quick. Having these little dots here really helps draw the graph. Make that a little longer. And let's say this is our graph. Definitely not perfect axes, but it works. Alright, x equals 0. That is the y-axis. Y equals 3. So let's say we want it here. And then y equals the square root of 3x. So that means when x is 3, y is 3. So it looks kind of like this. Kind of like this. And we want this area revolved around the y-axis. So we're going to take horizontal cross sections. That means if we're rotating about the y-axis, everything needs to be in terms of x, if I recall correctly. So we want x is equal to 3 y squared. And then we take the integral from 0 to 3 of pi times 3y squared dy. And that will give us the integral from 0 to 3 of y, no, not integral, pi times y, y cubed from 0 to 3. And that will give us 27 pi. And no, I have in fact forgotten how to do this. See, we stop doing math for even a single week, you forget how to do things. So first, let's see what is wrong here. Oh, why did I forget to write squared? Pi r squared. We forgot the squared. So that is equal to 9 pi and the integral from 0 to 3 of y to the power of 4 dy. That would turn out to be 1 over 5, so 9 over 5 pi y to the power of 5 from 0 to 3. You know, that doesn't look right either. From y equals 0 to y equals 3, yeah. Of pi times the thing squared, pi squared. It is over 5 now. Hang on, I'm gonna try to think about this for another minute. If I can't figure it out, I'll go look at my notes again. Y squared? Oh! I see what's wrong here. I didn't do my algebra correctly. I did my algebra big wrong. Y is not an x is in fact not 3y. It is in fact 1 over 3y. That explains a lot. So this is now 1 over 9 pi times integral of that, so it's 1 over 9 times 5. Actually, let's just write 45, which is equal to 3 to the power of 5. Let's rewrite this a little. 3 to the power of 2 times 5. That's 3 to the power of 5. So that's 3 to the power of 3 over 5 pi, which is equal to 27 pi. No, 27 over 5 pi. And that is the right answer. Anyways, now that we're done with A, let's move on to B. B wants to know the integral, not the integral, the volume of the region that you get by rotating this volume that's bound by y equals 9, x equals 3, and y is equal to 9 minus x squared about the x-axis. To find this answer, let's first draw a graph for this one too. But 9. How big does our graph need to be? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say that's our graph. All right. Make it even. Now let's see. We first need y equals 9, so that's this top line here. Then x equals 3, which is over here. and 9 minus x squared, which is over here. And of course on this side too, but we don't really care about this side. So we're rotating this area across the x-axis. The best method to use would probably be cross sections, and this is already in terms of x, which is great. So we take the integral from 0 to 3 on the x-axis of pi times the radius, which is 9 squared minus 9 minus x squared squared dx, upper minus lower. We solve for that, or rather we simplify a little first. We get integral from 0 to 3 of 81 minus 81 plus 18x squared minus x to the power of 4. Did I do that correctly? It's negative turns positive, positive turns negative dx. So that cancels out nicely, and we're left with pi times the integral from 0 to 3 of 18x squared minus x to the power of 4 dx. That can be integrated. So we get pi times 3, so 6x cubed minus 1 over 5 x to the power of 5 from 0 to 3. Plug in 0, we get 0. So plug in 3, we get... oh my god. Okay, let's do this. Pi times 3, 27. 6 times 27. I'm just gonna write it like this for now. Minus 27 times 9 to the power 3 to the power 2 over 5. So we get pi times 30 times 27 minus 9 times 27 all over 5. And we're left with pi times 21 times 27 over 5. That doesn't seem right. Yeah, it doesn't seem right. Okay, another mistake somewhere. From 0 to 3 of upper minus lower. Hang on a minute. Now that I think about it, is this cylindrical shell? Hang on. I think I might have done this entire problem wrong. My god, I am tired. But that is definitely not the answer. Well, let me just calculate it just in case. Just to make sure I didn't do any algebra mistakes. Wait. No, wait. This is right. The math in my head went wrong, but this is the right answer. Let me rewrite that. I don't know why math in my head went wrong. But this is the right answer. 567 over 5 pi. Once we're done with B, it's natural that we move on to C. C wants to know the area rotating bound by whatever you want to call the problem. Y equals secant x. Y equals tangent x. X equals 0. And x equals power 4. Rotated around about the x-axis. All right, let's draw our graph. Shouldn't need too big a graph, since this is after all trig function. There we go. And when I go secant x, that would be something like this, something like that. Tangent x would be a bit lower because it has to touch 0, 0. So we're bound by x equals 0 and x equals power 4. Hang on, where's power 4? About here. Welcome back, solo levels. It's fine, we're just drawing some graph, we're creating art here. If you just think about this as not mass, it works. And we need to rotate this about the x-axis, so this way. Let me actually draw my axis of rotation on all my work. Oops, don't mean to do that. And this needs to rotate about y-axis. Hey, if you've seen some of the terrible stuff around the internet, this isn't too bad for art, is it? Anyways, we likely want to do volume by cross-section. Torture. It's fine. Once you get used to it, it's not that painful anymore. Go get your food. You know, I remember I read something about why hell is terrifying. It's not because of any specific torture, but instead because it's eternal. The good thing about math is it's not eternal. So in that sense, it's not as terrifying. It's slightly not as terrifying as hell. Hell ain't scary? Am I the only one that thinks hell's scary? Oh man. I need to tell Satan to incorporate calculus into hell. Anyways, we want pi times the integral from 0 to power 4. Not all numbers are finite. Yes, I believe we do in fact have some problems with integrals from summer to infinity before. Well, I haven't personally went to hell before, so I can't really say what's like down there. Math will go on. Luckily, my life doesn't go on forever, so I don't have to deal with it forever. Anyways, too much dark stuff. We need the integral. of secant squared x minus tangent squared x dx. Oh man. Should I do this in terms of secant or tangent? Well, if you're religious, probably think heaven's a little better than hell at least. I don't know if they have calculus in heaven, but they should definitely add calculus as like the 10th layer of hell. Anyways, where was I? I distract myself. Is secant or tangent easier to deal with? I say tangent. So we're gonna put everything in terms of tangent. So 1 plus tangent x squared, tangent squared x squared. Wait, no. It's just 1 plus tangent squared x minus tangent squared x. Wait, I didn't even need to think about that. Alright. Hope you get a good dinner. I don't even need to think about whether to use tangent or secant because this cancels out perfectly. So we're left with pi times x from 0 to pi over 4. And we get pi squared over 4. Wow. That was surprisingly easy for how difficult the graph looks. Anyways, we have finished number C. Number C. Well, everything's are numbers everywhere. Anyways, next up we have D. D wants to know the volume you get by rotating the shape bound by y equals 3. Y equals square root of 3x. And the y-axis, so x equals 0. About x equals -1. One second. There we go. Draw or graph again. And we first have y equals 3. That's this line right here. We have or y equals 3x. Looks kind of like this. Goes across that way, goes down here. And then we have x equals 0, which is right here. And we want to rotate about x equals -1. So x equals -1 is right here. We rotate about this axis. Let me draw that better. Here's our axis of rotation. And we're gonna rotate this way. So this is another... Well, I suppose this one can be done by both cross-section and cylindrical shell. But I'm guessing we're meant to do cross-section. However, cylindrical shell would be a bit easier, if I remember right. Well, let's do cross-section. Because we already know that x is equal to 1/3 y squared. So now we can take the integral from 0 to... Wait. Oh, we need to find it ourselves. We need to take integral from 0 to 3. Pi times or outer, which is 1/3 y squared plus 1 squared minus 0 plus 1, which is 1 squared. And then dy. Simplify that. We get 1 over 9 y to the power of 4 plus 2 over 3 y squared. And the 1 minus 1 cancels out. dy. Solve for that, we get 1 over 45 y to the power of 5 plus 2 over 9 y to the power of 3 from 0 to 3. Plug things in, we get pi equals not pi equals, pi times 1 over 5, or rather pi times 27 over 5 plus 6. Okay, so that's about 57 over 5 pi. That is indeed the right answer. That was volume by cross sections. Let me see, what do I have next up? Number 2, which is another volume problem. All right. Let's see, start here. 2. For number 2, we have a right circular cone. It's described in words, so I'll just draw out the shape. The frustum of a right circular cone has a height of 10 meters, a base radius of 2 meters, and a top radius of 1 meter. So that means it's a decapitated cone. Something like this. A decapitated cone. A decapitated cone. That's like a tongue twister. And the top is going to be 1 meter. I think that's what it wants. Find volume. All right. First off, probably want to draw a graph. Although I just drew a diagram. Still need my graph. Let's just draw a really simple one. We have 10, 1, 2. Let's do that in blue. So y is equal to 20 minus x. Sounds about right. When we want to find the volume rotated across the y-axis. Easiest way to do that would be with cross sections. So we take the pi times the integral from 0 to 10. Oh, we need everything in terms of x, don't we? So we get x is equal to 20 minus y. And I just got a message. 20 minus y squared dy. So we simplify that. We get this is equal to integral from 0 to 10 of 400 minus 40 y plus y squared. dy. Hang on, that doesn't look right. There's no way it's this big. But let's finish this anyways. We get pi times 400y minus 20y squared plus 1 over 3 y to the power 3 dy. So we get pi, wait, why did I write dy? This is from 0 to 10. So pi times 4,000 minus 2,000 plus 1 over 3 times 1,000. Oh my god. But either way, that doesn't look right. You know, I don't know if I understood this problem correctly. The frustum of a right circular cone has a height of 10 meters, a base radius of 2 meters, and a top radius of 1 meter. So, is this not it? Maybe instead of 10, this is 5? Or is this a right circular cone at all? What's a right circular cone? Yeah, that's a right circular cone. Let me try it with 5 real quick. From 0 to 5 of x and squared doesn't seem like it either. What am I understanding wrong about this problem? Y equals 20 minus x. Wait. Another algebra mistake. Why didn't nobody scream at me? That's not y equals 20 minus x. That's y equals 20 minus 10x. So that's x equals 20 minus y over 10. So that equals x equals 2 minus 1 over 10y. That explains a lot. So we take the integral of pi times integral from 0 to 3 to 10 of 2 minus 1 over 10y squared dy. Simplify that, we get pi times integral from 0 to 10 of 4 minus 1 over 5 y squared plus 1 over 100 y. No, that's not y squared here. That's just normal y. Then dy. And just to make sure I didn't make another really simple math problem or math mistake. This equals to pi times 4y minus 1 over 10 y squared plus 1 over 300 y cubed from 0 to 10. Plug in 0, we get 0, so we get pi times 40 minus 10 plus 10 over 3, and that's equal to 30 plus 10 over 3, so we get 100 over 3. One second. No. That means I made another problem somewhere. Hmm. 100 over 10 times 1 over 10 is 100, yes. Takes the integral, yes. Oh man, what have I done wrong again? Let's check. Oh. X. What just happened? Okay, this is a algebra error once again. Some part of my algebra went wrong. Oh, I see. 2 times 1 over 10 is 1 over 5, but we have 2 of those. That was meant to be 2 over 5. So this will be 2 over 10, which is equivalent to 1 over 5. Which means we would have 20 minus 20, which in turn would give us 60, 70 over 3 pi. All right. That is number 2 completed. Which means next up we have number 3. Three wants us to use the cylindrical shell method to find the area formed by rotating the volume bound by x equals 4y minus y squared, x equals 0, about the line y equals -1. Start off by drawing your nice little graph. For y minus y squared. So if that was on the x-axis, it would look like this. If it's on the y-axis, it looks like this. You can draw that a little better. Looks kind of like that. Y is equal to 2, x is 0. Wait. Yeah. When y equals 0, x is also equal to 0. When y is 1, X is 3. Okay, I didn't draw that very accurately. This should be way over here. So it looks kind of like that. And x equals 0. Double check my graph. Yep. About the line y equals -1. So here is our axis of rotation. Y equals -1. Our cylindrical shell will be facing this way. That means we want the integral, or rather 2 pi times the integral from 0 to 2 of 1 plus y, or rather we should write that as y plus 1 times 4y minus y squared dy. Simplify that, or rather distribute it, FOIL it, we get 4y squared minus y cubed plus 4y minus y squared dy. So that turns out to be 2 pi times integral from 0 to 2 of 3y squared minus 3y cubed plus, wait, why did I write 3? Keep making mistakes like that. Plus 4y dy, which is equal to 2 pi times y cubed minus 1 over 4y to the power of 4 plus 2y squared from 0 to 2. So we'll get 2 pi times 8 minus 4 plus 8. Hang on. Is it? So that would be 12. That's 24. No. I think I made a mistake on every problem thus far. Let's double check. Is this algebra problem or is it calculus problem? Of x plus 1 times 4x minus x squared. Yeah, no, something's wrong with the integral itself. One plus y about y equals -1, yes. Oh wait, I drew my graph wrong. That's why. Let's redraw the graph. Fundamentally, the mistake was very simple. Instead of having a 2 here, this was meant to be 4. So our graph would in fact look a little more like this. 1, 2, 3, 4. 3, it'll look more like this. What a terrible graph, but you get the point. And we take cross section from there. We rotate across this axis. And that would be equal to 4 times 4, 64 minus 4 times 3, wait, 64 plus 32, which would result in 64 pi, which is right. Oh, wait a minute. I have found out that 3 is in fact composed of multiple questions. Only 2, not too bad. So let's move this to the side by a bit. This is our 3A. Now we need our 3B. B wants to know the volume, same by cylindrical method of y equals x. Y equals square root of x plus 2. Y equals 0 about the x-axis. Draw the graph. And we get y equals x. Here's our line number 1. Y equals x plus 2 squared. So that would start here and behave like a normal square root function. And y equals 0 about the x-axis. Hang on. Wait a minute. How will this rotation work? Is my graph correct? You didn't say x equals 0. Oh, around the x-axis. I somehow read that wrong. Or rather, I read it right, but then thought about it wrong. That makes a lot more sense. So, or each of our shell would be perpendicular to the x-axis. And we get 2 pi times the integral of, rather, the integral from -2 to, what does this intersect? 2. From -2 to 2 of x, or not x, y. So what? Hang on. I get the feeling I did something. Yeah, I did. I drew the graph wrong. Draw a graph again. Each of our shells will look like that. Parallel, not perpendicular. That makes a lot more sense. Then we can, let's move our integral down here because we need to solve for y first. Y, no. We need to solve for x. X. Oh my god, this is so annoying. Just erase that. I'll write it again. X is equal to y squared minus 2. And that one, x is just equal to y. So we get 2 pi times the integral from -2 to 2 of y times y squared minus 2 dy. Okay, which is equal to 2 pi times the integral from -2 to 2 of y cubed minus 2y dy. So for that, we get 2 pi times 1 over 4 y to the power 4 minus y squared from -2 to 2. So we would get 2 pi times 2, that's 4 minus 4 minus -2, we get, well, that doesn't sound right. That doesn't sound right at all, because that would be 0, which is in fact definitely not right. Okay, where did things go wrong? So my graph, oh, I see. It's my interval. It is in fact not from, wait, why did I do that? I don't have to erase all this. I just need to erase this. The integral's still the same, or bounds are wrong. Because it's -2 to 2 on the x-axis, but on the y-axis, it's going to be 0 to 2. Is that right? X goes 2, y goes 2. But wait. Wouldn't that just result in the same problem? Something else is amiss here. Did I read the question correctly? Y squared minus 2. Each of our shells is parallel to the x-axis. So there's our height. Oh, I for some reason forgot completely about the fact that we have two equations. So this is y minus y squared minus 2 dy. How did I make such a mistake? Just forgets about half the question. From 0 to 2 of y squared minus y to the power of 3 plus 2y dy. And then we get 2 pi times integral from 0 to 2 of, wait, not integral, we can solve this now. 2 pi times 1/3 y cubed minus 1 over 4 y to the power of 4 plus y squared dy. And we get 2 pi times, why did I write dy again? That's right, I'm doing this on autopilot now. I'm not even thinking. Well, this is from 0 to 2. So get 8 over 3 minus 4 plus 4. That doesn't sound too right either. Yeah, no, that's not it either. Right minus left, that's y minus y squared minus 2. Get y squared minus y cubed minus 2y turns into plus 2y. Oh, what is wrong? Alright, time to double check. Is my integral wrong? We want there is a problem with the integral itself. X equals y squared minus 2. I don't think anything's wrong with that. Unless... no, that shouldn't be it. Tricky. 2, 2 is where the two lines intersect. Read the problem again. Don't see anything wrong. What else can I double check? Yeah, nothing wrong here. Nothing wrong with the graph. Get 2 pi times y, which is our height, from 0 to 2, right? Of Nothing's wrong with this either. My answer would be 16 over 3 pi. But here it says the right answer is 44 over 15 pi. Which I frankly don't know how it got. I'm pretty sure I'm doing it right. I've double checked like 3 times already. You plug in 0, you do get 0. My algebra is... My algebra is correct. Is the answer wrong? How can I double check that? Let me see. Is there a guide somewhere? Volumes equal to the integral from a to b of 2 pi times x times f of x dx. In our case, we have y times right y minus left y. Oh. Wonder if I could Google this problem specifically. If I did this wrong, I don't know what is wrong. I think my answer is right. I know last time we did a problem, there was one question where the textbook had the wrong answer. And that had me confused for like 10 minutes. It could be happening again. Oh man. This is not even a textbook problem, so... This is the right answer. I firmly believe my answer is right. Where would you pull out of 44 and where would you pull out of 15? Everything done here is correct. There's no simple algebra errors. So unless I just straight up set up my entire integral wrong, this would be right. Even if my answer is correct, where would they get their answer from? I have to know. No, I guess I'll just never know. I will trust myself. I think my answer is right. I double check my work 4 times over. Based on what I learned about cylindrical shells, this is how I do cylindrical shells. We get 16 over 3 pi. Because we're rotating against the x-axis, right? X-axis is y equals 0. I am going to trust myself on this. I'm gonna not trust the answer we got given. Anyways, wait. Is that it for... Well, I suppose... Oh, these are all not in order. So that was mainly about volumes. This is just number 1. That was mainly about volumes, but... So question orders are kind of all over the place. We just did some volume reviews. Now we can do some work. Starting with number 4. Did I leave myself enough space? Yes, I did good. Or rather, I should leave myself a little bit more space. Four. We have a tank that's full of water. It's shaped like this. Decapitated cone that's upside down. It's got a upper radius of 5 feet. Lower radius of 3 feet. Ooh. It's got a height of 12 feet. And there's a straw coming out of it. The straw's height is 2 feet. And we need to figure out work done. The tank is full of water. Work done. Required to pump out water. Oh no, what is the density of water? Oh no. Let's see. It's 1,000 centimeter wait. 1,000 meter cubed over something. This question did not give me the density of water, and I do not remember. Let me find that. Oh, what do I use as a density for water? I'm gonna use water density at 4 degrees Celsius. I remember now. Back it was a physics or chemistry. We had to talk about density under different temperatures. Oh man, and I'm gonna say water density is 62. Let's just say 62 pounds per square foot. That sound right? Sounds about right. It's roughly rounded. But what's next? Okay. Let's see. Graph first. My lines are just getting less straight as I go on. We start at 3, end at 5. I'll start here and here. That is y equals 1 over 6x. No. Y equals 6x minus 18. Y equals 6x minus 18. So x would be equal to 1 over 6y plus 3. And we take density times pi times the integral from 0 to 12. of, or total height is 14 minus y times 1 over 6y plus 3 dy. Sounds about right. So we get 62 pi times integral from 0 to 12 of, ooh, more algebra. 14 times 1 over 6. That is 7 over 3y. Plus 28, 42 minus 1 over 6y squared plus, no, minus 3y dy. I don't like this. So get 62 pi times integral from 0 to 12 of, ooh, 7 over 3. So we're left with negative 1 over 6y squared minus 2 over 3y plus 42 dy, which is equal to 62 pi times integral from 0 to 12 of, wait, we can solve this, of negative 1 over 18 y cubed minus 2 over 6, or rather 1 over 3 y squared plus 42 y from 0 to 12. And I am not about to calculate that by hand. We get 22320 pi. That's a huge number. And pound foot. Is our number supposed to be this big? It is a big tank. And this one doesn't even come with an answer, so I can't double check. Let me think. Double check. Wait. I think I've done something wrong. You know what? Let's refer to a previous problem for some guidance. I believe work was over here, but 6.4. Should be somewhere near the bottom. Oh no. That doesn't work. Let's check out this convenient one then. Oh, wait, here's one. Here's a problem that's very similar to our problem. Wait, no, this is not exactly our problem. This is a different problem. But the process is largely the same, except there was a square here. Why did I square that? See, there's not enough work here to know. I didn't write down all the work needed. Because volume is pi r squared. Yeah, because volume is pi r squared. Oh my god. How did I forget that? I wrote pi r instead of pi r squared. Ah! Wait. This problem says set up the integral, so we don't have to solve it. No! I wasted all that time for nothing. So is this the right integral? Let's write estimate, not exactly 62. Volume is pi r squared. We have our pi already. And we have our two radius. So cross sections pi r squared times our height dy. No, it's 14 minus y. That's 2 plus 12. And I'm gonna trust myself. So there's that. Next up, we got number 5. 5 is returning to integrals, integration, the main meat and bones of calculus, of arcsine dx, arcsine x dx. Okay, so this one's pretty obviously integration by parts. U is equal to arcsine of x. Du is equal to 1 over square root of 1 minus x squared dx. And dv is equal to 1, v is equal to x. Right, so 1 dx. We substitute that, we get u times v, so that's x, arcsine of x, minus the integral of x over square root of 1 minus x squared dx. Do a quick u sub. U is equal to x squared. Du is equal to 2x dx. And we get, this is 1/2 of 1 over 1 minus u squared. Wait, shouldn't have done that. U is going to be the entirety of 1 minus x squared. Du is equal to, let's write this a little further apart. Du is equal to 2x negative 2x dx. So now this is equal to x arc sine of x minus, let's forget the first part for now. So this is plus 1/2 square root of 1 over square root of u, so that's u to the power of negative 1/2 du. Integrate that, we get 2u to the power of 1/2. So that cancels out with 1.2, and we just get u to the power of 1/2. So x arc sine of x plus u to the power 1/2. Rather, we shouldn't substitute yet. So that's x arc sine of x minus or plus the square root of 1 minus x squared plus c. Is that right? No answer? Alright. So let's double check by... I just have to double check my answers. Arc sine of x is in fact x times arc sine of x plus square root of 1 minus x squared plus c. Oh yeah, did I mention number 5 is also a multi-part problem? So after A, we got 5b, which wants to know the integral of x times natural log x squared dx. Oh, can we do a u sub? I don't think we can. If u is equal to natural log of x, du would be 1 over x dx. Dx would be x du, which is bad. Alright, then we need to do this with another integration by parts. We will likely have to do it twice. So let's say u is equal to natural log x squared. Then du would be 2 natural log x times 1 over x. So 2 natural log x over x. dv would be x, and v would... That's the x. dv is equals to x, v is equal to 1 over 2x squared. I'm just thinking, am I supposed to put dx here? Think I am. Yeah, I am. Multiplies that together, we get this is equal to 1/2 x squared times natural log of x squared minus 1/2 and 2 cancels out. So we get the integral of x squared and x cancels out once, integral of x natural log of x dx. That invites us to perform another integration by parts where u is equal to natural log of x du is equal to 1 over x dx. dv is equal to x dx. And v is equal to 1/2 x squared. And that would give us this minus 1/2 x squared natural log of x minus the integral of... Hello Volpus Lagos, welcome back. Yes, we're having more calculus. Today's mixed reviews. We are about halfway done, I'd say. We've just finished up with volumes and work. And now we're back to integrations. And where was I? Oh yeah, minus 1/2 and x, and 1 over x cancels out, we get x dx. So this entire thing is equal to 1/2 x squared natural log of x squared. Well, math homework is the best homework. Not saying any of them are good, but math homework is best homework. Minus 1/2 x squared natural log of x plus 1/2, that would be 1 over 4x squared plus c. And let's double check our work. Ugh. Okay. So their answer's very simplified. But they are equivalent. Fantastic. That is another problem done with. Next up, we have 2 more integrations. I assume these are all going to be integration by parts since they're so clustered together. C wants to know the integral of natural log of x over x squared dx. Can I integration by parts? I mean u sub. No. So we gotta do this integration by parts way. I would most likely want to have my u be your logarithms. So u is equal to natural log of x. Du is equal to 1 over x dx. dv is equal to x to the power of negative 2 dx. And v is equal to negative x to the power of negative 1. Multiply together, we get this integral is equal to natural log of x, or rather negative natural log of x over x minus, or plus in this case, the integral of x over x. So we get negative natural log of x divided by x plus x plus c. Is that right? Wait a second. No. Made mistake somewhere, I just realized. Another really dumb mistake. I should have erased everything. Oh no, Microsoft Whiteboard's lagging already. That's over x, and that's gonna be plus the integral of 1 over x squared. I forgot about this negative sign here. Dx. So this is equal to natural log of x over x minus 1 over x plus c. We can simplify that a little, so it's negative natural log of x plus 1 over x plus c. And there we go. That would be the right answer. Yes, it would be. Anyways, next up we have number 5D. 5D would like to know, down here. The cat is here. The cat has arrived. No, stop. There we go. Anyways, 5 wants to find the integral of square root of x times e to the power of square root of x dx. And oh god, what did it just do? Okay, continue. This one, can we do a u sub? Or is it going to be integration by parts again? If I do integration by parts, that would take like 2 steps. No, would that even work? I think this one can be done with a u sub. Let u equals x square root of x du would be equal to 1/2 times x to the power negative 1/2 du. And yeah, dx. Wait, not du over here. Over here is supposed to be dx. If we solve for dx, that is equal to 2 square root of x du. Yeah, so this way we get 1/2 integral of u times e to the power of u du. Wait. No, this is just 1/2 e to the power of u du. Still here. Okay. That would give us 1/2 u e to the power of u, which would give us 1/2 square root of x times e to the power of square root of x. Wait, that can't be. That sounds too simple. If that's the case, then where's my problem? Is this the answer? No. I, in fact, did not do this correctly. So where did it go wrong? Is this another integration by parts? Dx is equal to square root of x. Wait. Hang on. What if instead of u equals square root of x, we did the opposite? So x equals u squared. Hello, Arnable Coca. We're doing some mixed calculus reviews. So x is equal to u squared. Dx is equal to 2u du. This could work out. So we would get the integral of u, or this would be 2u squared times eu. No, this is just calculus, mass in its purest form, du. Do they do this in engineering class? I know that they do this with velocity and acceleration. I have done a couple engineering courses before, but this is just calculus, plain old calculus. Okay, so we have 2 times u squared eu. We will probably need integration by parts. We are having an exam coming up very soon, but I'm not too nervous about it. Let's say, what should we say? Oh god, I just realized what a terrible thing I just did. If I want to do a u sub now, I already have u. Hey, that's why the channel is called Anon's Nightmare. Let's do fg instead. I think that works just as good. Let's say f equals u squared. df. Wait, we can call this f prime. Is equal to 2u du. And then we can have f and g. G would be equal to e to the power of u. And hang on. G prime would be e to the power of u. In college, you study agriculture. I think I've seen agriculture class before, but I have no idea what they do inside agriculture. What do they teach you? Like maybe weather conditions, things like that? I have no idea. And e to the power of u just turns to e to the power of u. So we get... So this is equal to 2 times u squared e to the power of u minus 2 times u eu du. Oh, livestock, crops, and of course business. I have to teach you business summer. And there's even certifications for agriculture. Agriculture is one of those what do you call it, courses side I just never touched on, that I have no idea, zero clue what it's about. And even meteorology. There's also agro-engineering. Oh, there's so many different fields. All I really know is math and computer science, and that's it. But why do we need to know meteorology in agriculture? The risk of a meteor impacting your farm? Anyways, we need to do another U sub. This one is for UEU. U times e to the power of u du. Engineering courses, some of them are very math focused. Others require you to do a bit of integration, but I remember one of the ones I took was mostly about 3D modeling. And that was actually pretty fun. That was where I learned to model. You need to learn how to predict weather. What about weather forecast? Are you not allowed to use those? Geez, it's the power of u. Oh, du. There we go. So this would be equal to u minus e to the power of u du, which is just e to the power of u. So all in all, we get 2 times. Farms have their own weather. Oh. Maybe it's more accurate because it's in your exact area. That's cool. You can predict your own weather. Oh, farms have their own ecosystem. I suppose a weather forecast wouldn't really just go out 10 miles into the middle of nowhere to take a weather sample. But that is pretty cool. And here we would have our answer. Turn it back into x. U is equal to square root of x. Holy crap. This is a long answer. And this is correct. Most important part. Ooh. This looks terrible. One day, farmers can just predict the weather without the use of any tools. They just know the weather. They smell the air and they know what the weather is gonna be. That's actually probably possible. Really experienced farmers probably can actually do that. With x minus 2 square root of x minus 2. Damn. I want to learn that power to just be able to tell the weather by smelling the air. But then I never go outdoors anyway, so it would be wasted on me. And this would be the right answer. Ooh, number 6. We have another volume problem. Number 6 wants to find the volume of the solid generated by revolving the region in the first quadrant bounded by the coordinate axis, the curve y equals e to the power of x, and x equals natural log of 2, x equals 0, y equals 0, about x equals natural log of 2. I have friends say the same thing. Like, they could do every subject. You throw them into any subject like chemistry, physics, whatever subject, they'll do fine, but they just can't do math. They said it's because with science, things like chemistry, you can explain every number. Every number has some kind of meaning, like a gram, a pound, some kind of measurement. But in math, it's just numbers, and they don't get that. Is it the same thing for you? Let's draw a graph. Yeah, I wonder, can I use this ruler? How do I use this ruler? How do I rotate it? How do I rotate ruler? Yeah, I don't know. Math isn't really creative. I wouldn't say math is creative either. It's more like a puzzle game where there's a very specific way you have to go to reach your answer. Sometimes there's a few ways, maybe 2 or 3 ways. Most of the time, you just take the shortest path to the answer. And that's what math is all about. And we draw a graph. See, the procedure to solve this problem is basically written in stone. We draw a graph first. Goes through 0, goes up. Natural log of 2 is, let's say natural log of 2 is right here. We also revolve around this axis. Yeah, with science, you know what you're doing. Like, we're doing an experiment. Every step is something. But in math, you don't know whether or not you did it right until the very last step. And then if you did it wrong, well, good luck checking your work. Science proves itself, but math doesn't. Anyways, we also want to bound by the axis, so this part revolved around this axis. Easiest way to solve this problem would be with a cylindrical shell. So let's do just that. This is equal to 2 pi times integral from 0 to natural log of 2 of natural log of 2 minus x times e to the power of x. Dx. Hey, that's why we have jobs as mathematicians. Because some people don't like math, we can do the math for them. Yeah, it seems like this. The only thing you can explain about this problem is now I know the volume of this weird shape rotated around an axis. It's not like, oh, I know when you mix this chemical and this chemical together, this thing happens. You just get a number that you can't use. And let's see, did I write this integral correctly? Yeah, I think I did. statistics is really cool. Statistics probably the most creative way you can use math, especially with the part where you can use statistics to your favor. Like I remember an example they gave us in school. We have a graph that shows something, some data, and it's really exaggerated, but what they don't tell you is that it starts at like 1000. You can basically use statistics and graphs to exaggerate data, things like that. I think that part about statistics is really cool. The most useful thing I've found for calculus so far is finding the volume's useless. Position, velocity, and acceleration. That was pretty much the most useful thing about calculus so far. It's used in physics, and that's the only place I've ever actually used it. So this is e times natural log of 2, no, e to the power of x times natural log of 2 minus x ex dx. So we got more numbers piling up. And luckily, because I did that before, I know that x times e to the power of x, I know that. If you take physics C, you will use calculus, but outside of that, I have never seen calculus outside of the classroom. And never. So we get this times e to the power of x, natural log of 2, minus x times e to the power of x, plus e to the power of x dx. Not dx. Why did I write that again? From 0 to natural log of 2. So we'll get 2 pi e to the power of x times natural log of 2 minus x plus 1. From 0 to natural log of 2. And that would give us 2 pi e to the power of x, no, e to the power of natural log of 2, so that's just 2. E and natural log cancels out. So that's 4 pi times natural log of 2 minus natural log of 2 is 0, so that's just 1. Wow. What a clean solution. Wait. No. No, this is not it. Yeah, the lower level maths, like especially elementary maths, you actually use a lot every day. But the higher up you go, the less useful it becomes. So what went wrong here? Natural log of 2 minus ex. That part's right, and that part looks right too. I believe my integral is correct, so this is likely an algebra mistake somewhere. Factored out ex. Here it says the correct answer is 2 pi times 1 minus natural log of 2, which is not what I got. Although sometimes the answer they give is wrong. I believe that's happened twice already. Once, what, 2 days ago and once today. How did this come about? Alright, let's check this out. Is this my integrals problem or is this my algebra problem? Back to the bags. And here's the problem. If you want to check your work, this is a lot of things to check. Is my integral correct? I did solve the integral correctly. I don't know how I'm doing this either. I'm just following the procedures. Step 1, 2, 3, 4, 5. Okay. I guess I did solve the integral wrong. All integral is this sign, this weird stretch out S. But somewhere along the way, my algebra went wrong. My integral's correct, I solved the integration correctly, and then I do algebra wrong. That's 2 pi is power of x, natural log 2, 1x, yes. So how does it get from here? Oh, I realized. I just realized. I'm dumb. I didn't finish the problem. Because if you plug in 0, you don't get 0. So this is 4 pi minus 2 pi. Natural log e to the power of 0 is 1. Natural log times natural log of 2 plus 1. So 4 pi minus 2 pi natural log of 2 minus 2 pi. That gives us 2 pi and that's 2 pi. So 1 minus natural log of 2. Is that right? That is right. There we go. Finally. Just forgot to finish the entire problem. Okay. We are... Ooh, actually, we're still pretty far away from finished. Next up, we got 7, which is back to integration. 7a wants to know the integral of cosine of natural log of x dx. Ooh, that's a problem. Cosine and natural log stacked on top of each other. Can we do u sub? Can we do integration by parts? Actually, can I do u sub? Agriculture study streams would probably be more entertaining than this. That is a pretty cool idea. Biology was a subject I didn't touch too much on. I learned a little bit about it. Arts is the thing I can't do. Like, everybody has something they can't do. Sometimes it's math, sometimes it's science. Arts is the one thing I cannot do. How do various cage types of collect chicken? Oh my god. That is very specific. That is oddly detailed. That is oddly detailed. Okay. How do I approach this? U sub, no. Integration by parts, maybe. Let's try parts. I have no idea how to solve this problem, to be honest. Let u equals to cosine of natural log of x. Du equals sine or negative sine of natural log of x times 1 over x dx. You know how to solve this one? Am I doing it right? dv is going to be equal to dx and v is going to be equal to x. That way this x can cancel out. So we would be left with, I think this is how we solve it. X cosine. Press the X button. My grade wouldn't like that very much. Minus that X cancels out, so this is a plus. Sine of natural log of x dx. Okay, it makes so much sense now. This is how it's done. I have achieved enlightenment. This is where the dopamine hits, when you figure out a problem that you don't think you know how to solve. But it only happens every so often. Du is going to be equal to cosine of natural log of x times 1 over x dx. I think this is the first time I've seen a problem like this. And then dv is equal to dx, v is equal to x. It cancels out. I mean, it does kind of subtract from the experience now that calculators can do all of this if you just type it in. There's not even a point to manually doing all this anymore. Yeah, I get that feeling. When math snapped for me was, I think, geometry. When we were writing proofs. And that was when math finally snapped. Because out of the entire class, I think I was the only one who could actually do it. X sine natural log of x. Hopefully I'm writing this right. Minus the integral of cosine of natural log of x dx. Now we're back exactly where we started. Aha! And if we're back exactly where we started, exactly, you can just learn to use a calculator instead of learning how to do this by hand. And the fun part is that this is all equal to cosine natural log x. Symbol Lab. I think I've seen that website before. Symbol Lab is one of those sites that solves every single type of math problems you can throw at it. And oh my god, did I figure this one out? There we go. Fantastic. Let's check the answer. Let's watch the calculator solve it in the time it took me like 10 minutes to solve. Let's watch the calculator solve it in a second. And I got it right. But the calculator was way faster. I suppose they have to teach this kind of stuff for people to start making those calculators. But once those calculators are out, they're just so much more efficient than solving it by hand. B wants a definite integral, and one that hurts much more to look at. The integral from 0 to power 2 of cosine squared 3x sine cubed 3x dx. Oh man. I think I know how to solve it. Think. This is equal to the integral from 0 to power 2 of cosine squared 3x times 1 minus cosine squared 3x times sine of 3x dx. That would mean we get integral from 0 to power 2 of cosine squared 3x. Or rather, let's do a u sub now to save some time. U is equal to cosine of 3x. du is equal to 1/3. No. Du is equal to 3 sine negative 3 sine 3x dx. Let's see. If that is the case, then we have there is a free website called integralcalculator.com that shows you all of the steps for free. That is the one I use. And unfortunately, we can't use the calculator on an exam, so I do still need to know how to do this. It's very time consuming, but it's not too difficult. So we'll get u squared times 1 minus u squared times negative 1/3 du. Looks about right. So we get negative 1/3, or rather, this is no longer the integral from 0 to power 2. This is now the integral from somewhere to somewhere that I'm too lazy to figure out. Yeah, but I'd rather not cheat on the exam. This integral from somewhere to somewhere. U squared minus u to the power 4 du. Sometimes doing math is fun. It's like we need to just turn your brain off, or rather turn the creative part of your brain off for an hour or so, and then just sit there doing some math. After you write an essay, you got a brain drain, you have no idea what you're doing anymore. Just sit down, do a couple of math problems, finish the math homework. And it does wonders to remedy insomnia. And that is going to be negative 1/3 times 1/3 sine, no, cosine cubed 3x. I generally will never recommend cheating on exams. But let's be honest, when are you not going to have a calculator when you need math outside of class? And dx? No dx. There's not even du here. This is definite integral. From 0 to power 2. From 0 to power 2. Is that right? Here comes the fun part. Cosine of 3 pi over 2 is... that's pi over 2. Wait. 3 pi over 2. Oh my god. Where's 3 pi over 2? 3 pi over 2 is somewhere over here. Over here. Wait. Finance math probably the most important math you can learn, just because taxes and organizing, of course, we have to use math every day. So much of the world is just numbers now, but there's not really any integrals out in the world. Wait, cosine 3 pi over 2 is 0. That means cosine 0 is 1. Oh man, I'll tell you. Anything artistic or creative related, I am terrible at. So things like writing essays, drawing, playing music, I can't do any of that. Like essays, yeah, I can write some okay essays, but it hurts my head. Statistics is really good. I forgot, do they require you to have taken calculus when you go to statistics? I think you need to have like AP Calculus 1 before you go to statistics. I think that's how it worked in my school. So we get 1 over 9 minus 1 over 15. Uh-oh. Is that 2 over 45? see. I can do integration, sure, but when I have problems like this, I still pull out the calculator, and that is correct. That is correct. Oh yeah, to do the deep min-maxing stuff, you do need to know how to do calculus. You do need to know how to integrate. Interpreting graphs, you actually have to sync. Unlike me just going on autopilot here. You're basically emulating a calculator by doing these problems. Number C wants the integral of 6 times cosecant cubed x over tangent x dx. I think we can make it look a little better first. Oh yeah, as I was doing computer science, trig actually turned out to be really useful. All the trig stuff, sine, cosine, all those turn out to be very useful, especially when you're doing things with 3D. Let's see, cosecant is 1 over sine. So that's 6 times 1 over sine cubed x times tangent is sine over cosine. So that's sine x cosine x dx. So that is equal to 6 times cosine x over sine to the power 4x dx. Okay, that is an easy problem. We do a u sub, u is equal to sine of x, du is equal to cosine of x. Be a PNG tuber. Yeah, I thought about all the different things you can do with VTubing, a PNG tuber, 2D VTuber, 3D one. And I figured that because I can't draw, the best option I have is to go 3D. And I used a program called VRoid Studio. It was available on Steam. It is really easy to use that thing to make a avatar. But I also learned Blender to do stuff like this. Just some little augments here and there. When I make a really dumb mistake, I can just press a key and this happens. Anyways, so now we can rewrite this integral as 1 over u to the power 4 du. So then we would have 6 times negative 1/3 u to the power of negative 3 du, which is equal to negative 2 times, what's u, sine of x. In this case, negative 2 over sine cubed x. Let's see. Oh man, depending on what you're good at, the best choice will differ. Like if I want to be a PNG tuber, I would have to draw. And every piece of art that I touch becomes something terrible. And just impossible to look at. Alright, anyways, let's check this answer. Blender, the first hour of Blender was a nightmare. Blender was the most complicated program that I have ever learned how to use. It's even got a video editor built in. It's got everything you need. Man, there's so many buttons you don't know what to press. It took me like days to figure out how to use Blender. Commissioning probably a good idea. I thought about doing commission too, but in the end, I wanted this channel to be about improving. So if you read the about page, we do an improvement every day. Not every day, every week. And I try to learn things in the process. I like to try to do things by myself as much as possible. But if there's things I can't do, like art, I will have to just commission stuff. I did use some resources found around the internet. There was on Boost, a website that I saw in one of the tutorials for like the hair. Because my god, let me tell you, when I tried to make the hair on my own, it did not look like hair. Same for the skin texture, really, if you don't want to be the default texture. I just can't draw anything. Best I can draw is a graph. Anyway, 6 cosecant x to the power of 3 divided by tangent of x. Let's go. And is correct. Fantastic. Now we can move on to the next problem, which is D. D wants to know the integral of dx over x squared times square root of x squared minus 36. X is greater than 6. Now this problem here hurts my eyes. Can we do u sub? Let's see. 1/2. Or rather, no, we cannot do u sub. That means we probably have to dabble in the arcane art of trig substitution, where x is equal to 6 secant theta, if I remember correctly. That means dx is equal to 6 secant theta tangent theta, which would mean our integral can be rewritten as 6 secant theta tangent theta over 36 secant squared theta times the square root of or rather times 6 times the square root of secant squared theta minus 1, which would translate to tangent theta. So let's do just that, tangent theta, d theta. Simplify that further, we get 1 over 36 times the integral of 1 over secant, which is cosine theta. Integrate that, we get 1 over 36 sine theta. And if we draw a triangle, the trig triangle, triangles are another one of those really useful math subjects. The theta. Secant is opposite over, no, hypotenuse over opposite. So hypotenuse is x, opposite is 6. Adjacent is oh god, x squared minus 36. Right. hypotenuse over, rather, hang on. No, secant is cosine. Secant is 1 over cosine. So if cosines is adjacent over hypotenuse, secant would be hypotenuse over adjacent. So that is the right one. X squared minus 36. Okay. Sine is opposite over hypotenuse, so we just have 1 over 36, wrong color. 1 over 36 times x squared minus 36 over x. Alright, is that correct? Is that correct? Go. Calculator 1, 2 seconds. Calculator 2 seconds. And it is correct. Fantastic. Don't forget our plus C. That is D done with. Oh my god. Scroll to the next page and you see something even more terrifying. Oh my god, there's still 3 full pages to go. I am nowhere close to finish. I just realized that. We might need to take a commercial break somewhere in between. Anyways, E wants the integral of x squared plus 9 over 5x squared dx. This one. How would I go solving this one? Can't complete the square. Can try a U sub, but U sub won't really work. The only logical conclusion is trig substitution once again. So because it's x squared plus 9, we will likely have tangent. X is equal to 3 tangent theta. Dx is equal to 3 secant squared theta d theta. That would allow us to rewrite this integral as the square root of 9 tangent squared plus 9. That would be 3 secant theta over 5 x squared is cool crap, 945 tangent squared theta times or d theta 3 secant squared theta d theta. Okay, so overall we have 1 over 5 secant cubed theta over tangent squared theta d theta. Double check really quick. Factor out of 3. Get tangent, turn to the secant. Okay. So rewrite this again. 1 over 5 times secant is 1 over cosine, so that's 1 over cosine cubed theta times tangent, or 1 over tangent, which is cosine of cosine squared theta over sine squared theta d theta. Is that right? Which is equal to 1 over 5 times the integral of 1 over cosine theta sine squared theta d theta. Oh no. How would I solve this? Could I have used 1 minus tangent squared up here instead? Don't know if that would have helped. That actually, I think, would work. But can this be an easier way to do this? Also, why did I write a 5? And why did I write a 2? This is supposed to be 5. 1 over cosine theta 1 minus cosine squared theta would turn to secant theta minus secant cubed theta. That would work. That would work. All right, let's do that step by step then. And Microsoft Whiteboard's frozen again. It's equal to 1 over 5 times integral of 1 over cosine theta 1 minus sine squared theta d theta turns into 1 over 5 times integral. Why did I write sine here? This is cosine. Keep making really dumb mistakes like that. I'll do that. Okay. What am I doing again? Oh, right, integration. We get 1 over cosine theta minus... Ooh. Can we do that though? Minus cosine cubed theta. Are we allowed to say this is now secant theta minus secant cubed theta? Can I do that? No, I cannot. Oh crap. Guess we'll have to try another way. Integrate secant 3 theta over tangent squared theta. What if we try 1 plus tangent squared theta times secant theta over tangent squared theta? That way we end up with 2 integrals. Secant theta over tangent theta, the tangent squared theta. Wait, how would I solve this one? Ah, this hurts when your integral doesn't work out. Is trig substitution not the way to go? But there's no other way to solve this. Oops, I got lost inside again. How could I solve this? If I multiply by tangent theta on both top and bottom, that wouldn't really work either. I am for once stuck. The difficult part is now that there's a random secant on top. It's an odd power secant divided by even power tangent. I think I need some help. All right. Let's see what the machine says. Use the identity. Wait. Oh, it's simplified and rewrite. Wait a minute. Oh my god. I think I realized it now. Oops, where's my... Okay. So this is at first equal to 1/5 cotangent squared theta secant cube theta. Wait. No. We write this as 1 over cosine. So hang on a second. 1 over cosine theta sine squared theta translates to what? Secant theta cosecant squared theta. Now we use an identity. So that is equal to 1 plus cotangent squared theta d theta. Is that right? Yeah, I think so. But now we would get secant theta plus secant cotangent cotangent squared theta d theta. Now cotangent is cosine over sine. Secant is 1 over cosine. That would mean 1 over cosine. This is cosine squared over sine squared. So that's cosine over sine squared, which is 1 over sine and cosine over sine. So that's cosecant times cotangent. Cosecant theta, cotangent theta. D theta. It makes so much sense now. Solve that. You get 1 over 5 times. Bring this up a little for context. 1 times secant. Oh my god. Integral of secant is natural log of secant theta plus tangent theta. And then plus, or rather, this would be minus cosecant theta. Right? Let's check. Yep, that's right. And if that's right, we just gotta plug everything back in now. Draw our little trick triangle. This is theta. So if opposite, tangent is opposite over adjacent, we get opposite over adjacent. And here we have x squared plus 9. Now we plug everything back in. It equals 1 over 5 times natural log of secant of secant is 1 over cosine. So that's hypotenuse over adjacent. Tangent is opposite over adjacent. Minus cosecant is 1 over sine. So that's hypotenuse over opposite. I don't know why it works, but it works. And then plus c. Let us double check the answer. Square root of x squared plus 9 divided by 5x squared. Ooh. It is... Hang on. Why don't they have to divide by 3? Huh? Why doesn't their answer have divided by 3? Hmm. That is how. Factor 103. They did integration by parts. Computer thinks the right way to do this is integration by parts. Oh, I see why now. I see why integration by part works. Can't believe I didn't see that. But oh well. This works just as well. That's one minor problem. Damn. Did I type it in correctly? Yes, I did. I need to go through the step by step. Wait, I see my problem. Where do I? X is equal to 3 tangent theta. So tangent theta is equals to x over 3. I do not know. Five secants cubed. Yeah. Integral is right, but why does their answer not have divide by 3 here? I need to know. How did they simplify this into something else? Wait a second. Okay, we need to take a quick commercial break, so let me put you on hold. 1 second. Oh my god, I was muted. So I'm trying to figure out how they went from this to this. Because this is equal to my answer. But my answer is not equal to this answer. It said apply the absolute value function to arguments of logarithm functions in order to extend the antiderivatives domain. And I have no idea what that means. I am extremely confused. But this answer is right prior to simplifying it. But how did this simplify it to get from here to here? I do not know. We'll just leave it at that. I don't know what kind of black magic they did to simplify it further. Now we're down to F. F looks like a pretty obvious one. X over x squared minus 4x plus 8 dx. Now this is very obviously a partial fraction. So let's write that. X over x squared minus 4x plus 8 is equal to, or rather, we need to factor this first. How about, we might need to complete the square. x minus 2. That doesn't work. Oh no, this is not as simple as I thought it was. Complete the square. So that's x minus 2 squared plus 4. Or rather, can we straight up do this quadratically? But that wouldn't help. This is already the simplest quadratic one. What can I do? A U sub? I'm just incapable of thinking at this point. This definitely looks like partial fractions, but how can we make this a partial fractions? I do not know. I'm gonna need some help with this one. My god, what kind of black magic is this? This looks even more terrifying than before. You can write x as 1/2 2x minus 4 plus 2. But why? How would you know that's what you should write x as? Just so you could split the fractions? I guess this is the simplest way you can just write x longer. But we never learned about this. If I don't do this, how would this work? I will trust it for now and go along with it. So that would be equal to x minus 2 over plus 2 times wait, could I've done partial fractions? No. What about here? Here I can't really do anything either. Oh, wait a second. What is this? Yeah, we do a U sub. Oh, okay, that works. I know that part works, but what about the one? What kind of black magic is this? Okay, this part's easy. That's 1/2 the integral of 1 over u du. But this half, u is equal to x minus 2 over 2. How was I supposed to know that? Du would be equal to dx. So that's 2 times 1 over x is equal to 2u plus 2. So that would be 4u squared plus 4u plus 4, and then the 4x will turn to negative 8u plus wait minus 8. So that would be 4u squared minus 4u minus 4. No. Yes. Oh, there's another plus 8 there. So that's 4u squared minus 4u plus 4. So that would turn into, hang on, is that how it works? Wait, no, did it complete the square first? This is the most difficult problem so far. Would integration by part work? I can't think of anything that would work for this. So x minus 2 squared plus 4, that's completing the square. So I have a natural log of u plus 2 integral of... Here's the confusing part. Well, actually, I do know how to solve this. Because this looks like an arctangent. So we just need to factor out a 4. So we let u be equal to 1/2 x minus 2. D would be equal to 1/2 dx. That would turn this into the integral of 1 over 4u to the power of 4 plus 4, and then 1/2 dx times 2 du. So that would turn out to be 4. So this is that 4 and 1 over 4 cancels out. 1 over u to the power of, wait, to the power of 2, right? Now how does they do it? We did the same thing. U plus 1 du. So that is equal to 1/2 natural log of u plus arctangent of u, which would be equal to 1/2 natural log of x. There should have been natural logs everywhere here. X minus 2 over 2 plus arctangent of x minus 2 over 2 plus c, right? Wait, no. This u is different. That's a different u. This u is equal to x squared plus minus 4x plus 8. Let's leave us a little more space. And that would be correct. I would not have known how to solve this problem. This is the one problem I do not know how to solve. This one, even this one, yeah, if I think about it a little more, I can get to there. But this problem, first step, how am I supposed to know this? But I suppose this will work for basically every problem structured like this. So that's something new we learned. But besides learning, we also gotta complete the homework. So let's move on to G. G wants us to find the integral from... So indefinite integral of wrong color. Wait, am I lining it up correctly? G wants to find the indefinite integral of 36 over x cubed minus 9x dx. First things first, the U sub is a big no. This is another one of those slightly harder problems. This is equal to... Wait a second. Evaluate, okay. Equal to... let's say 36 times x squared minus 9. So that's x plus 3, x minus 3. Right, if that's the case, then this is an easy problem. But after the last two problems, I don't know whether I can trust myself anymore. Okay, write our partial fractions. This is equal to a over x plus b over x plus 3 plus c over x minus 3. So 36 is equal to a times x plus 3 x minus 3 plus b x minus 3 plus c x plus 3. And now if x is equal to 0, a is equal to 36 is equal to negative 9a. So a is equal to negative 4. If x equals 3, then 36 is equal to 3 times 6, 18. C is equal to 2. Right? 3 times 6, 18, yes. If x is equal to negative 3, b is equal to... that's 0, that's 0. B would be negative 3 times negative 3 minus 3. So that is positive 9. So that would also be 2. Yep. So we rewrite our integral as negative 4 over x plus 2 over x plus 3 plus 2 over x minus 3 dx. Solve that, we get negative natural log of x plus 2 natural log of x plus 3 plus 2 natural log of x minus 3 plus c. There's our answer. Okay, is that correct? So let's double check. 36 divided by x to the power 3 minus 9x. That is 2, wait. No? Oh, how did I forget? Negative 4. There we go. I forgot to bring this negative 4 down. There we go. Now we have the right answer. Right? Yeah, that's the right answer. Finally, we got H. h wants us to find the integral of cosine of t over sine squared t minus 10 sine t plus 24. It looks complicated, but this is not that hard of a problem, I promise. That is because we can do a u sub right off the bat, where u is equal to sine of t and du is equal to cosine of t dt. Knowing that, we can simply rewrite this integral as du, or let's just write 1 here. 1 over u squared minus 10u plus 24 dt. No, du. Because cosine t dt is equal to du. That matches perfectly. Next up, we simply do our partial fraction, actually. 1 over, let's write it a little closer this way. 1 over u squared minus 10u, that would translate to u minus 4, u minus 6 is equal to a over u minus 4 plus b over u minus 6. So 1 is equal to a times u minus 6 and b times u minus 4. Now, if x is equal to 6, 1 is equal to 2b. So b is equal to 1/2. But if x is equal to -4, 1 is equal to -2a. A is equal to -1/2. Did I do my algebra right? I think so. So we can simply rewrite this as the integral of -1/2 over u minus 4 times, rather plus 1/2 over u minus 6 du. Simplify that, we get, or rather integrate that, we get -1/2 natural log of u minus 4 plus 1/2 natural log of u minus 6. No du. Plug in or u back, we get -1/2 natural log of sine t minus 4 plus 1/2 natural log of sine t minus 6 plus c. There's our answer. Fantastic. Double check the work. Cosine t divided by sine t squared minus 10 sine t plus 24. Okay, right. Natural log of 6 minus sine x. How does that come to be? The natural log of sine minus 6 minus natural log of sine minus 4. Once again, apply the absolute value function to the arguments of logarithm functions in order to extend the antiderivatives domain. I don't get how they simplified that. Oh, I just realized. Because sine is always between 0 and 1. Sine t minus 4 is... wait. Is the same as 4 minus sine t? Is that how it works? Well, I think that's how it works. Test out some values. Yep, I think that's how it works. Must have been the same for the previous problem as well. That's why I was so confused at how they simplified. But we don't need to do that. As long as the answer is right, Gunnet? We don't need to do all the simplifying. If you simplify it wrong, you get points off. But if you don't simplify, you don't get points off. Alright. We are somewhere close to finish. When did I write so much? Okay, let's get back. Let's create a new column. Oh no, I need this to be precisely at 100%. Everything must be perfectly aligned. Everything must be perfectly aligned. There we go. No! Where's my 100% zoom? 100%. There we go. Fantastic. Okay, that was starting from this line. We're up to number 8. Let's give it some space. 8 here should be fine. Yeah, I don't think I use too much space per column, so 8 here will be fine. Number 8 says, use the trapezoidal rule and Simpson's rule with n equals 4 steps to estimate. Okay. Let's write this down. Estimate the integral from 1 to 3 of 2 over x squared dx using trapezoidal rule. And n is equal to 4. So I assume that means we have 4. We divide this integral to 2. And find an upper bound for the error for both cases. Wait a second, what does that mean? Find an upper bound for the error for both cases? Both cases? What do you mean both cases? We're not using rectangles. Let's draw a little graph. Okay, 2 over x squared. So approach infinity as x approaches 0. As x approaches 1, it approaches 2, x approaches 2, it approaches 1/2. So it goes like this. And the other side too, but we don't really care about the other side. And we want it from 1 to 3. So from here to here. Okay, I positively have no clue what they're talking about when they're talking about finding upper bound for the error for both cases. Like, what do you mean both cases? Trapezoid, what's Simpson's rule? I've done this kind of problems before. Oh. I swear, none of these people that write textbooks speak English. Each blue line. If n equals 4, then I assume that would mean we take the area from 1 to 1.5, then 1.5 to 2, then 2 to 2.5, then 2.5 to 3. That would give us 4 different trapezoids. How does this work? Okay, where do I see a trapezoid? Here's our graph. Let me draw a bigger version of our graph. Let's say this is starting at 1. Our graph looks like this. Our graph looks like this. So then at x equals 1, and then x equals 2.5. Let's make it look bigger. 1, 2, or like that. We draw trapezoids to estimate the area. We draw a trapezoid, a trapezoid, a trapezoid, a trapezoid to estimate the area. That part's easy enough, but what the hell is it talking about when it says find an upper bound for the margin of error for both cases? Especially this part that says both cases. Oh, I think I know. I think I know what they're talking about. All right. So trapezoid rule, simple enough. We take... Oh god. I have to solve this by hand. 2/1 minus 2 over 1.5. Wait. F of 1 plus f of 1.5 and divided by no times 0.5 divided by 2. So that would be divided by 4. Is there an easier way to write this? I suppose it suffices. Times f of 1.5 plus f of 2. So let's simplify all this a bit. F of 1. I do like math. Math homework at least is best homework. F1 plus f of 1.5 plus f of 1.5. Wait. How about 1/2 f of 1 plus f of 1.5 plus f of 2? It's like a puzzle game. Like when you finally solve a problem, it gives you a sense of achievement. F of 3. There's a form of gratification after you solve a difficult problem. Unlike an essay, where if you write an essay, you think, oh my god, I think my essay is really good, and your teacher reads it like, yeah, no, this essay is a failure. Wait a second. So this would all be divided by 2 again. Okay, so let's have x and fx. X equals 1, 3 over 2, 2, 5 over 2, and 3. X equals 1, fx is equal to 2, x equals 3 over 2, 9 over 4, so that's 8 over 9. And x goes to 2, that's 1/2. 5.5 over 2, that's 8 over 25. 3, that's 2 over 9. To me, at least, math homework is the easiest homework. Anyways, do I have to solve all this? 1 plus 8 over 9 plus 1/2 plus 8 over 25 plus 1 over 9 divided by 2. Yeah, no, I'm not solving that by hand. The one thing I don't like about calculus is algebra. Yeah, you have fun with your sleep. I will need to be here for a little longer. So that is equal to 141 over 100. Yeah, I think so. This would be our volume, and our margin of error would be 1 over n squared is equal to 1 over 16. 1 over... No. N squared equal to 16. Which is greater than 10 to the power 1. This is less than 10 to the power of -1. Is that what it means both cases? Okay, trapezoidal rule means we get a margin of error that is less than 1 over 10. But Simpson's rule my god, this is so confusing. Okay, wait. I think I get it. This is done by trapezoidal rule. I do not believe we ever learned about this. At least not the margin of error part. Then Simpson gone. Either we never talk about this or I didn't pay enough attention in class. Okay, so b minus a, 3 minus 1 over 3 times 4, or 3 times n. And f of x of 0 up to n minus 1. How do I estimate with Simpson's rule? Mm. How does this work? I definitely do not recall the Simpsons rule at all. Okay, 3 minus 1. Wait. So delta x is equal to our bounds 3 minus 1 divided by our interval, which is 4. And then we need 3 minus 1 over 3 times 4 times f of 1 plus 4 f of 3 over 2 plus 2f of, what is this, 2 plus 4f of 8 over 25 plus f of 3. I think I get it. I think I understand Simpson's rule now. So we have 1, 4, 2, 4, 2, 4, 2, keeps repeating 4, 2, and the last one's a 1. So that's how Simpson's rule works. And this would be equal to what? Oh my god. Or 6 times 2 plus 2 over 9 plus 1 plus 72 over 25 plus 2 over 9 fraction that, we would get, okay, you know what, that's too big a fraction, we're just gonna leave it in decimal form. Let's give it 3 digits. Let's just give it 2 digits. As for margin of error, to calculate the margin of error, we use n times b minus a to the power 5 divided by 180 n to the power 4. Think of what is our m? What is m? Oh, is m the margin of error? Wait. So the fourth derivative of our function is less than or equal to m. What does that mean? Back to the PDF. So Okay. Welcome back, Hola GSD. Mathematics carry no meaning until such a physical meaning is assigned. That is true. We are, for some reason, estimating volumes, or rather estimating areas, where we can straight up solve for the area. As for this one, too general, estimating area, we need to take the force derivative of this 2x to the power of negative 2. If you have a good real world example, it does make understanding it a lot easier. As for what I'm reading, I don't know if the person who wrote this PDF speaks English. Like, I cannot understand it. So f prime of x is equal to negative 4x to the power of negative 3. F double prime x is equal to 12x to the power of negative 4. F triple prime x is equal to negative 48x to the power of negative 5. F quad derivative of x. Integral ends in capacitors. Does capacitors have to do with area too? This is negative 2, no, positive 240 x to the power of negative 6. Double check. Yep. Now, f quad prime of 3. Now, I don't know anything about capacitors yet, but I do know that area means integral. Ooh, it can't do 3 to the power of negative 6. 3 to the power of 6. The voltage across a capacitor is scalar multiple of the definite integral of the current flowing into it. Ooh, that's in electronics. Kind of does make sense, but I don't know anything about the details. Oh, hang on. This would be... Huh. Where does a B minus A go? Oh, 1. So this is 270 over 729 times 3 minus 1 to the power of 5 over 180 times 4 to the power of 4. Which is equal to 2 times 2, about 2 times 2.3 times 10 to the power of negative 4. Let's rewrite this to a decimal as well. I'm normally a fractions gang, but in this case, a decimal would be cleaner to look at. Okay. So the margin of error would be, let's say it's approximately, yeah, it wants upper bound, so this is approximately 6.3 times 10 to the power of negative 2. Would be the upper margin of error. But that doesn't make too much sense because the error is already much greater than that. One over 60 error is understandable. But the second one's not as understandable. The actual area would be, let me find it. Integral from 1 to 3 of 2 divided by x squared dx. The actual area is 1.33. But that doesn't make sense. Oh no. Okay, you know what? We'll leave it at that. I'm like 200% sure we never talked about this. Chalk it up to manufacturing tolerances. I remember something my engineering teacher used to say is that you miss a decimal, people will die. Like if you make the tiniest bit of mistakes, people will die because of you. But in the end, yeah, manufacturing tolerances. Some products look nothing like what you ordered. Anyways, estimate the minimum number of subintervals. To approximate to 4 of 1 over x minus 1 with error less than 10 to the power of negative 4 using Simpsons. Why have I never even heard about the Simpsons rules before? And why is this in the homework? Same equation or same formula, m equals b minus a to the power of 5 divided by 180 n to the power of 4. So first off, here comes the derivatives. Oh my god. I'm gonna keep taking derivatives of this. Well, I suppose it's actually pretty easy. Since derivative of x is just 1. And finally, f quad prime of x is equal to 24 x minus 1 to the power of negative 5. And f quad prime of our upper limit, which is 4, will be equal to what? 24 times 3 to the power, or rather 24 divided by 3 to the power 5. Would be equal to 8 over 81. So that's our m, right? I think that's what it means. Wait. The derivative of a constant is always 0, yes. We're just plugging in a number here to check. Well, where does that power come from? Since this is the right one, so our margin of error is 8 over 81 times 4 minus 2 to the power of 5 divided by, wait, not 18, 180, divided by 180 times n to the power of 4. And we need to solve for n. This needs to be less than or equal to 10 to the power of negative 4. Okay, so n to the power of 4 is greater than or equal to 8 over 81 times 4 minus 2 to the power of 5 divided by 180 times 10 to the power of negative 4. A divided by 81 times 2 to the power of 5 times 10 to the power of 4 divided by... It's kind of what I'm doing right now. Divide by 180. N to the power of 4 needs to be greater than 58, or let's call it 59. typing an x into a calculator takes about as much effort as just moving one variable around. I think it's fine for now. Hang on, if we use square roots. This isn't right. It says the answer is 16. But this is not 16. How did that happen? Hmm. Dimension 1. And 1 over. What if there's no this here? Wait, 10 to the power 4. That means n would have to equal to at least 4 to provide us with the accuracy of within 10 to the power negative 4 to the actual answer. But the answer is supposed to be 16, so I have done something wrong. Oops. Well, I have never learned about this in class. I don't know why it's on the homework. Wait.
In estimating the definite integral,
Let's see, I found an example somewhere. Yeah, let's start over here. So E 10 over -4 must be less than or equal to, or number 4 minus 2 to the power 5 divided by 180 times n to the 4th power times max f4 of x, whatever that means. Never seen this before. Oh, the maximum value of this graph? The maximum value of this graph would come from infinity. This graph has no max value. It's a max value on 4 interval. So let me actually bring up a graphing calculator. Desmos, the best online graphing calculator. 24 times x minus 1 to the power -5. And it's 24. That's 32 over 180 into the power 4 times 24. Ah. So this is in fact not it. We weren't supposed to plug in the number. So n to the power 4 is greater than or equals to 32 times 24 divided by 180 times 10 to the power 4. Which means n to the power 4 has to be greater than or equal to that. Now we simply solve it. We get 14.37. But with Simpson's rule, n has to be even, so we have to get the greatest even number. The greatest even number that's above this number. That explains everything. That means I did the previous problem wrong too. I am a master of the Simpsons rule now. Wouldn't have to show analytically. You're right. So analytically, the graph looks something. The graph looks something like that. You know it because it's got a approach infinity, and because this is an odd power, it also approaches negative infinity. So the graph looks something like this, with the center being around x equals 1. Like that. As x approaches 1, y approaches infinity and negative infinity. And if that's 1 or 2 must be the highest value. So f quad prime of 2 is equal to 24. And that's how we would know that this is 24. Hope that made sense. But that means we gotta redo the last part of the previous problem because I had the wrong idea on what to do. It shows that there exists no point within the interval where the derivative of the function equals 0. Oh no. Well, we can say that the derivative is never equal to 0 because f f5 prime of x is equal to negative 120 divided by x minus 1 to the power of 6, which can never equal to 0. The derivative of this function can never be equal to 0. And it has a constant decreasing slope when x is greater than 1. Let's see, you have to show no point within the interval function equals 0. Oops, let's open this up. This one is a vowel and the boundaries must be at a maximum. Alright. Good reminder. We will show it right here. This can never be equal to 0 because denominator cannot be 0. Now here then, we have a very similar situation. If we try to graph it, that would be, oh. Yeah, I personally wouldn't bother either. I don't even know what I'm doing right now. I'm just following instructions on the PDF and it's working. As x approaches 0, y approaches infinity. And of course, let's do the same thing here. So the f5 prime of x is is equal to 240 times 6 negative 1440 x to the power of negative 7, which cannot be equal to 0 under any circumstances. And this one wanted is the integral from 1 to 3, if I remember right. 1 to 3. So we want f quad prime of 1, which would be our highest point, which would be 240. So here, instead of this weird number, respond. This would be 240. 240 times 32 divided by 180 divided by 4 to the power of 4 is equal to 1.7 times 10 to the power of negative 1. f5 prime of 0 be equal to 0? No, in fact, because f5 prime of x is equal to negative 1440 divided by x to the power of 7. And you cannot plug in 0. If you plug in 0, you have something divided by 0. That's right. Yeah, that's a negative power. And I guess we would also have to show that it's undefined. It's never undefined on this interval as well. But I think we just know it's continuous from the graph. But did I do anything wrong for this trapezoidal? Go. But that doesn't make too much sense again. Any trapezoidal rule? Yeah, no. We gotta do the same thing basically for trapezoidal. So for trapezoidal rule, it's error is less than or equal to absolute value. Error is less than or equal to b minus a 3 minus 1 cubed divided by 12 and squared, and then the max. But this time the max is with f double prime of x. Yeah, yeah. F double prime of x is 12. The max of f double prime of 12. Let's just write it here. F double prime of 1 is equal to 12. So this is equal to 32 times 12 divided by 12 times n squared. That would mean for n is 4. Huh? 2? Two? Is it that broad? I suppose it is. Trapezoidal is not very accurate after all. And this one, oh no, not the undo. That's right. Let's erase or a little square. Let's write it as e is less than something. E is less than or equal to 1.7 times 10 to the power of negative 1. And there is Simpson's rule and trapezoidal rule. That should be it, right? Please don't tell me there's more. Holy crap. That took all the time. Now then, The hard part is over. But this Microsoft Whiteboard is lagging so much. It's running at like 1 FPS. It can no longer handle the calculus. Please just zoom to 100 precisely. Why does it only go up and never down? Oh, it's at 100. Perfect, perfect, perfection. All right. We're almost done here. Next up is number 10, which is our final problem, but composed of 3 parts. 10a wants us to find the integral from 0 to infinity of 1 over x squared plus 1 dx. Wait, do I know how to do this? I don't know if I know how to do this. But this is equal to arctan. The integral part's easy. This is arctan of x from 0 to infinity. But how do I do this part? Let me first check out arctan. I forgot what arctan looks like. Okay, arctan, yeah, I remember now. Why did I forget? You understand. We find the finite integral and take the limit of the resulting subtraction. Let's see. So this also has to do with limits. Oh my god. How long has it been since I last done limits? Let's see. It's a cat again. Limit of a10 should be pi over 2. So what does that mean? We have limit x to the power of infinity. No, limit x towards infinity of arctan x minus limit towards 0 of if that's the case, then the answer would be pi over 2 minus 0, which is equal to pi over 2, which would be the right answer. Wait, it's this easy? I thought it'd be a bit harder. Okay, next up, we got B. Thank you. B wants the integral from 1 to infinity of 1 minus x times e to the power of negative x dx. Now, how can we solve this? U sub, probably not. Actually, yeah, probably not U sub. Likely integration by parts. So let's have our u be 1 minus x, du would be negative dx. dv can be e to the power of negative x, and v would be negative e to the power of negative x. Laplace transform instead the boundaries from 1 instead of from 0. Laplace transformation. I haven't heard of that term before. What is this? Oh, it does look kind of like it. You got does look kind of like it, but not exactly. We'll probably run into them later. But once we integrate that, we get negative, rather, integral from 1 to infinity of negative 1 minus x e to the power of negative x minus, wait, why did I write integral? Should have wrote an integral. This is just x minus 1 e to the power of negative x minus e to the power of negative x dx, which gives us x minus 1 e to the power of negative x plus e to the power of negative x from 1 to infinity. Now it takes the limit. Hang on, let me double check my integral. Looks about right. We take the limit of, as x approaches infinity, of this thing go. As x approaches infinity, e approaches 0. As x approaches infinity, f of x approaches 0. Oops. Minus x approaches 1 of f of x. Should probably add this is equal to that equals f of x, but it's fine. So as x approaches infinity, f of x approaches 0. So we got 0 minus x approaches 1. 1 minus 1 is 0. E to the power of negative 1. So this would be equal to 1 over e to the power of 1. So just negative 1 over e. That's it. Wow. Finally, not finally, we got c, which wants the integral from negative infinity to positive infinity of e to the power of x divided by 1 plus e to the power of 2x dx. Now this one looks like it could use some u sub. Let's say, oops, u is equal to e to the power of x, du is equal to e to the power of x dx. Now we can rewrite our integral as integral from negative infinity to infinity of 1 over 1 plus u squared du, which is equal to, rather, I shouldn't write the bounds for the integral, not this one. It's the integral from summer to summer. but this is equal to arctangent. So arctangent of u from somewhere to somewhere. Plug things back in, we get arctangent of e to the power of x from negative infinity to positive infinity. As x approaches infinity, arctan approaches, let's write it down. Minus which is equal to, as x approaches infinity, arctangent approaches power 2. Approach negative infinity. Hang on. No. X approaches negative infinity. Tangent 0 is 0. So this would be power 2. Wow. That's it again. Why is the last two problems easy? Usually the hardest problems are last. Now we want integral from 3 to infinity of 2 over x squared minus 2x dx. That looks like a partial fraction. So we can do 2 over x times x minus 2 is equal to a over x plus b over x minus 2. So 2 would be equal to a times x minus 2 plus b times x. If x is equal to 2, then 2 is equal to bx, or 2b, so b equals to 1. If x is equal to 0, 2 is equal to negative 2a, therefore a is equal to negative 1. That means we can rewrite our integral as from 3 to infinity of negative 1 over x plus 1 over x minus 2 dx. And that means we can now do this is equal to natural log of x, negative natural log of x plus natural log of x minus 2 from 3 to infinity. So let's do that. Limit as x approaches infinity. Ooh. Natural log. Hang on. What does natural log do as it approaches infinity again? But wait. These two would kind of cancel out because natural log decrease the slope of natural log decreases as x gets higher. So this would be 0. That would be 0, and that would be negative natural log of 3, and natural log of 1 is 0. So that would be natural log of 3. And that is correcto. Fantastic. We're done here for today. That took a bit longer than expected, but I tried to distribute my space evenly. I try to make all the columns have the same length, but then here in the middle, we still have some really long. All right. Microsoft Whiteboard can barely handle this mess anymore. So hey, Anybody here? Thanks for checking the stream out. And especially you, Hall SGD, thank you for the help. I wouldn't have remembered limits without you. But we have finally reached our conclusion for today. Next calculus stream next Saturday. Monday, Wednesday, we still have our lobotomy corporation stream until I manage to finish that game. But everybody have a good night. You hate math? Ah, that's unfortunate. A lot of my friends hate math too. You can toss them into any other subject, whether it's chemistry or even other subjects that uses math, like chemistry or physics. They do fine, but they just can't do math when it's by itself. Anyways, have a great night. See ya.